This is the end of 2-1, or the continued part of Chapter 2, Lesson 1. And we're going to talk about the independent variable and the dependent variable. The independent variable is the x value, and it's generally what you plug into to solve the equation or to figure out, well, where am I going to plot this point? The dependent variable is the y value, or the output. So the y kind of sits around and it's like, okay, whenever you choose something, plug it in and tell me what I'm going to be. So it depends on what you choose for x. The value for the y is, it only happens when you choose an x. So if I had something like 3x plus 2 equals y, then in order for y to have a value, I've got to give x the value first. I could pick a 1 for the x, like when we set up our tables. If I put in a 1 for x, I would have 3 times 1, which is 3, plus 2, which is 5. The 1 being plugged in for the x is what caused the y to have its value. So the y had to just sit and wait. It depends on x. All right. The other thing is function notation. Now, function notation is where we have, you're used to seeing y equals 5x minus 1, or an equation that's written in this way. We're saying if it's a function, it can be written like this, where you replace the y with f of x. So y and f of x, this again, that's read f of x. Some people may say f at x. But we can rewrite it, and y and f of x mean the same thing. So suppose you want to find the value of the range, that's the y value, that corresponds to the element -6 in the domain. Since we're saying -6 is in the domain, we're saying that -6 is the x value. So we could do that using function notation and say f of -6, or the function evaluated when x is -6, f at -6. There's many ways that you can read this. So what you do is, if you see something like this, that means that our x value is -6, and we can plug it in for the function. So we would plug in x here, or it would be over on this side because we've written it as f at -6. Plug in the -6 and solve the equation to figure out what y is. And so this is what they've done here. Let's try these two. So it's telling me to evaluate the function at -3. And since it normally is written like this, we know the x is -3. So we write down f at -3 equals, and rewrite this part, because we wrote this with the -3 in there. Rewrite your rule and plug in -3 for x. So -4 times -3 minus 8. So f at -3 equals 12 minus 8. Continuing on, f at -3 equals 4. This would be our result. Now, if you were looking at the graph, you could plot a point and it would exist at -3, 4. Let's try this one. So we're going to evaluate g at 5. And everywhere I see an x value, I am going to plug in 5. So -2 times, the x is squared, so 5 is going to get squared, minus 4 times 5 plus 1. G at 5 is, remember, do your order of operations correctly. We have to do exponents first, so it's -2 times 25 minus 4 times 5 plus 1. Yes, you can write this in shorter steps if you'd like, but make sure that you solve everything correctly. -50 minus 20 plus 1. G of 5 equals negative 70 plus 1. So G at 5 is negative 69. Again, if we were to see this on the graph, you would have a point plotted at 5, comma, negative 69. And of course, you write all points with parentheses around them. All right, that is all for Chapter 2, Lesson 1. So let me know if you have any questions, and I'll see you later.